Okay, today we're going to be talking about basic fraction operations. This is meant to be a review of things you learned in elementary school. These notes might be a little bit long, and the lesson in class might actually span a couple of days, but I want to get them all into one video. So let's start with adding and subtracting fractions that have like denominators. This is our best case scenario. When the denominators are the same, all we do is keep that denominator and add the numerators. So 2/7 plus 1/7 is 3/7. Same for subtracting. If we have the same denominator, in this case we do, we're going to just subtract the 9 and the 3 to get 6. Remember that you always want to simplify your answer. So since 6 and 10 are both divisible by 2, we can make this 3/5. Down here there are some examples to try on your own. Keep the denominator the same, subtract the numerators. In example number 2, keep the denominator the same, add the numerators, and then whenever possible simplify. Both 10 and 12 are divisible by 2, so we can make this 6/5, and that's your best answer. So now let's move on to adding and subtracting with unlike denominators. All of the directions that you need are up here that you can review if you need to, but I'm just going to walk through it with you. So we need common denominators. So we want to find the lowest common multiple of 12 and 8. Now, one way is to multiply 12 and 8, right, and get yourself 96 and use that as your denominator. That would be a common denominator, but it might not necessarily be the least common denominator. Using the least common denominator means that you're going to be working with smaller numbers and do less simplifying at the end. So the smallest number that 8 and 12 go into evenly is 24. So I want to get denominators of 24. Let's use some color here. So since 12 times 2 is 24, we can do 7 times 2 to get 14. And since 8 times 3 is 24, we can do 3 times 3 to get 9. Why does that work? Well, because you can do 7/12 times 2 over 2, and really that's just multiplying 7/12 by 1, right? Because 2 over 2 equals 1, and you're allowed to multiply anything in math by 1 and not change its value. So that's how come it works. Now that we've got it, though, let's solve it. 14 minus 9 is 5, and then we keep the denominator the same. I can't simplify that because 5 and 24 don't have any common factors besides 1. All right, so let's look at this next example here. We have 5 and 10 as our denominators. They are not common denominators. I'm going to change it to have common denominators. The smallest number that 10 and 5 both go into evenly is 10. So since we multiplied 5 times 2, we can multiply 2 times 2 to get 4, and 1/10 is already a tenth, so we'll leave it. And then I'm going to do 4 minus 1 to get 3 and keep the 10 the same. And our last example in that section, we have a 6 and a 15. So some multiples of 6 would be like 6, 12, 18, 24, 30, and the first one that 15 goes into of the multiples of 6 is 30. So we're going to use 30 as our common denominator. This is an addition problem. So since we did 6 times 5, we're going to do 1 times 5. And since we did 15 times 2, we're going to do 8 times 2. And then we're going to add together 5 and 16 to get 21. And I can simplify this because 21 and 30 are both divisible by 3. So if I divide by 3, I'm going to get 7/10, and that would be my best answer. All right, great. Let's move on to multiplying. Multiplying, I feel like, is almost, well, the common denominators with adding and subtracting is pretty easy too, but multiplying is just, you don't need common denominators. You don't need common denominators for multiplying or dividing, which makes it a little bit easier than the adding and subtracting. You can just multiply straight across, like 1 times 2 is 2, and 2 times 5 is 10, and then simplify by dividing by 2. Or you can cross cancel, which I love because it means that you're simplifying less at the end and working with smaller numbers. You can say that 2 goes into 2 once, and 2 goes into 2 once, and then 1 times 1 is 1, and 1 times 5 is 5. Same answer, right? But smaller numbers to work with. So let's try cross-canceling in the next example. So cross-canceling means you're looking for common factors across from each other. So 3 goes into 3 once, 3 goes into 9 3 times, 2 goes into 2 once, 2 goes into 16 8 times. Then I'm going to multiply 1 times 3 to get 3, and 1 times 8 to get 8. And I don't have to simplify because I did all of that canceling out in the problem before I multiplied. Okay, let's try this one down here. Let's cross cancel. 4 goes into 4 once, 4 goes into 8 twice, 5 goes into 5 once, 5 goes into 15 3 times, 1 times 1 is 1, 2 times 3 is 6, and that's my answer. Ta-da! All right, this last example, I can cross cancel here, but not the other way because 12 and 7 don't have any common factors. But 5 divided by 5 is 1, and 25 divided by 5 is 5. So I'm going to do 12 times 1 is 12, and 5 times 7 is 35. No common factors with 12 and 35, so that's my final answer for that one. And then let's move on to division, our last operation here. Again, all of the directions in words can be found up here, but I'm just going to talk you through it to save time. So when we divide fractions, we are going to take that first fraction and keep it the same. We're going to use the reciprocal of the second fraction and multiply. Some of you guys learned that as like keep change flip or something like that, or keep change change. 6th grade teachers have some cute ways for you to remember it. But we're just going to use the reciprocal of the second fraction and multiply. Then it's just like the multiplying. So you can do cross canceling and get 7/8 here. And then for this one, I'm going to take the first fraction, multiply it by the reciprocal of the second fraction, cross cancel where I can, and I'm going to get 3/4. Remember that you can also just multiply straight across and simplify. So if I have 9/20 times 5/3, I can do 9 times 5 is 45, and 20 times 3 is 60. And if I divide 45 by 15, I get 3, and 60 divided by 15 is 4. So you can see I end up with the same answer. I'm just working with bigger numbers if I don't cross cancel. And sometimes you can't cross cancel at all. It's not possible. So let's take this first fraction in example 3 and multiply it by the reciprocal of the second fraction. I can cross cancel here, and I'm going to get 5 6 because I'm doing 2 times 3. For the last example, for these notes, I'm going to do the first fraction multiplied by the reciprocal of the second fraction. Here I can cross cancel, make 1s. I can divide by 8s here. So I'm just going to get 2/3. That's it, guys. Thanks for watching.